Okay, so we're going to move on to Chapter 8, titled Volume and Surface Area. So today we're going to work with a volume of cylinders. So name and date. Okay, so we've got some different cylinders here. We're going to talk about their volume and what that means. So the volume of a cylinder. Now in class I would take apart a cylinder, this one, and when we take this apart we see that a cylinder is made up of a top circle, a bottom circle, and then one long curve that ends up looking like a rectangle in between. So when you put the top and the bottom, it curves together, or another thing that we've talked about is it looks kind of like a division sign. So when you curve it together, you've got a top and a bottom, and then a curve that comes around. So we've got two formulas that we're going to use for volume of cylinders. You can use this one where it has volume is equal to the big B, where that's the area of the base, times H. But I use this one, pi r squared H, because it is more specific. It tells me exactly what I need. I need pi, I need the radius, and I need the height. So a couple vocab words. Pause me when you need to. Volume is the measure of the space occupied by a solid. So this space is occupied by paint. So this one, if we're talking about its volume, would be the volume of paint inside, the volume of pop inside, the volume of various foods on the inside. A cylinder is a 3D figure with two parallel congruent circular bases connected by a curved surface that when you undo it ends up looking like a rectangle. The area of the base of a cylinder tells the number of cubic units, so that means that volume is always going to be units cubed for a label in one layer. The height tells how many layers are in the cylinder. Recall that the radius is half the diameter, so when we're working with the radius, make sure it's half of the diameter, and that the formula to find the area of the base of the cylinder, that's a circle, so area is pi r squared, so we're going to take the area times the height to find the volume of a cylinder. Process that I like to consider here is to write down the formula, make sure you have the radius, plug and chug. I'm going to show you how to use a pi button, or you can use 3.14. Depending on the directions on your assignment, you can either use the pi button, but if it says use 3.14, especially on riddles, make sure you use 3.14. Check your rounding, check your label. Find the volume of the cylinder, round to the nearest tenth. I've got the radius, I've got the height. So I'm going to write down my formula, pi r squared h. Pi, I'm going to rewrite as just pi. The radius is 5, so I'll leave the 5 squared, and the height is 8.3. So that's how I write mine down, and I can actually type all of that in my calculator, or I could reduce this to like pi times 25 times 8.3. But I'm going to type in pi button, which is the fourth one down, times 5 squared times 8.3, round to the nearest tenth, so 651.9 centimeters cubed. And there's my volume. I am done. The next one does not have a picture, but it says find the volume of a cylinder with a diameter of 16 inches. Well, that means that the radius is half of that, so 8 inches, and I need to have the radius, and a height of 20 inches, round to the nearest tenth. So volume equals pi r squared h, pi times 8 squared times 20. I can type it in my calculator just like that. Pi 8 squared times 20, 4,021.2. So the volume is 4,021.2 inches cubed. I'm going to show you what would happen if I use 3.14 instead. So 3.14 times 8 squared times 20 is going to give us a very similar answer, but a little off. So the bigger the number, so these are in the thousands, the more off we're going to be. This one is more exact because we used actual pi, so just be careful when you are doing these to read the direction. A metal paperweight is in the shape of a cylinder. The paperweight has a height of 1.5 inches and a diameter of 2 inches. So that means the radius is 1 inch. How much does the paperweight weigh if its cubic inches weigh 1.8 ounces? So we're going to go ahead and find the volume here. Volume is pi 1 squared times the height. Now 1 squared is just 1, so I can kind of ignore that. So really it's just pi times 1.5. And that's 4.7. I'm going to keep that number in my calculator, but this is 4.7 inches cubed. Well, they say that 1 cubic inch is 1.8 ounces. So 4.7 cubic inches, if I multiply those two numbers, so then I can show you my label, ounces per cubic inch. My labels would simplify out. So I'm just going to keep this number in my calculator and take it times 1.8. Round to the nearest tenth, 8.5. So the volume is 8.5 ounces. So that's the only label left, and we're talking about, this is not volume, we're talking about weight. So there's an extra step when you're given weights. This is the same problem, same type of problem. There's a container that is shaped like a cylinder to recycle aluminum cans. So it's a cylinder full of cylinders. It has a height of 4 feet and a diameter of 1.5. Well, that means that the radius is 0.75. Don't round that. Keep that. The container is full. How much do the contents weigh if the average weight of the aluminum cans is 37 ounces per cubic foot? So we need to find the volume. So pi radius squared times the height of the container, 4. So pi 0.75 squared times the height, 7.1. I'm going to leave that though in my calculator, 7.1 feet cubed. But that's times 37 ounces per cubic foot. So I'm going to be left with ounces. If I take my number in my calculator times 37, you get 261.5. It's not volume. It's 261.5 ounces is what we're left with. That's how much it weighs. So watch the label on weights. Okay, a couple other things that we can do. We can put shapes together. So those are called composite solids, vocab word. Objects made up of more than one type of solid are called composite solids. To find the volume of a composite solid, decompose or break apart the figure into solids whose volumes you know how to find. So this one, when you have a composite figure, it's a multi-step with either adding, so if they put two shapes together, we're going to add their volumes, or if they take something out, we're going to subtract it. So Tanya uses a cube-shaped beads to make jewelry. Each bead has a circular hole through the middle, so there's a cylinder cut out. Find the volume. So we've got a cube, so I'm going to be really specific and really organized and say I have a cube and I have a cylinder. And I'm going to subtract those volumes because I'm removing the cylinder. To find the volume of a cube, that's length times width times height, or they're all going to be the same, so you could do side cubed, minus the volume of a cylinder, pi r squared h. The length and width and height are all the same, 12 times 12 times 12, or 12 cubed, minus pi times the radius, though, if we look here, this is all the way across, so that's 2, so the radius is actually 1 millimeter. Again, kind of pointless to do a 1 squared, because it's still 1. And the height of the cylinder is the same height as the cube, so 12. So 12 cubed, 1,728, minus, I'm just going to do 12 pi here, because the 1 squared doesn't count, 37.7. So now I can do 1,728 minus 37.7 and get that the volume of the composite solid is 1,690.3 millimeters cubed. Okay, so that was where we removed a cylinder. So here we have two shapes. The Service Club is making storage chests like the one shown to donate to a charity. Find the volume of the chest to the nearest tenth. So I see a half cylinder up at the top, so I'm going to call that a half cylinder. And I see a rectangular prism at the bottom. So the volume of a half cylinder is going to be the same as a cylinder, but in half. So I'm just going to bring that half down, and that's pi r squared h. And I'm going to have to add these together because there's one on top of the other. Rectangular prism is length times width times height. Now I can plug in what I know. I'm going to change a half to 0.5. You can do that too. Pi is an ugly decimal, so it's okay to end with a decimal on all of these problems. Pi, the radius, well, that's this distance, half of that. They don't give me that, but they give me 25. So that means that this is 25, and 25 divided by 2 is 12.5. So the radius is 12.5 squared times the height, and the height is the distance between the bases. So the height of the cylinder, the half cylinder, is actually 50. Be careful with that one. The height of the rectangular prism is going to be the same thing, so we can put that in for height when we get there. And the length and the width of the bases, so 30 and 25. The order does not matter there. The height is 50. So you can actually type all of this in your calculator in one step, which I'll show you. 0.5, you have to just be careful. Pi times 12.5 squared times 50. You have to be really careful. And I don't really want to screw that up, so I'm actually going to do it in two steps. So there's my first one. 12,271.8 plus, and I'm going to do 30 times 25 times 50 separately, 37,500, and then add them together. So that's going to be 37 plus 12 is 49, so the volume of this is 49,771.8 centimeters cubed. Okay. And this one we're just going to set up, and then you can finish it. So it's just similar. Platform like the one showed is built to hold a sculpture for an art exhibit. What is the volume? So the volume, we see a cylinder. So that's volume equals pi r squared h. And I also see two rectangular prisms. So those are actually, if we look at all the dimensions, they're all the same. So I put a 2 out in front here, and I would have a 2 down here, and then length, width, and height. And then I would just plug in all my numbers. So I bring my pi. My radius is, let's see, this is all the way across is 8, so the radius is 4, times the height, which is 15 of the cylinder, plus, bring my 2 down. This is going to take care of both rectangular prisms. The length and width are 20 and 8, and the height of the prisms are 5. So then we can go through and do those numbers. We're going to get yada, 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 meters cubed. There is no elevator to success. You have to take the stairs. Have a great day.